Welcome to the Ultimate C++ course, where you're going to learn what you need to know about C++. This course is in chapters, so you're going to visit each and every one one by one. Yeah. So to start with, the first chapter, that's the introduction to C++. So the main objectives in this chapter is to learn why we should use C++, to learn difference between C and C++, learn the object-oriented concept of C++, and then the standard library to understand C++ program development, difference between process and threads, and explosive program. So the C++ programming was created by Björn Strustrup. This is the name, Björn Strustrup. Barne Strustrup, right? Strustrup. So this is the name, Björn Strustrup, with capital B. Sorry, Björn Strustrup. That, and looking this setup, this initial setup from here to down here to this one, excluding the name, is the uh is the what's this is a standard um is a standard format for C++ program. Yes. So this is the name Björn Strustrup. He created C++ language in 1979, formerly called C with classes. Now, C++ was coined by Rick Massity in 1983. Yeah, so this is 1979. Then it was coined by Rick Massity in 1983, commercially released in 1985. Now, C++ evolved from C in mid 1998. So the next, why we should use C++? So C++ is used in every computing system. It's efficient, close to the machine language. That's the system programming language. Then C++ has object-oriented programming. C++ is a compiled language, universally usable in modular programs. Now, the object-oriented programming. The object-oriented programming is to identify components called objects, specify relevant data and possible operations to be performed on that data. The programming language, the object-oriented programming is a programming language that implements OOD, which is the object-oriented design. Sorry, a programming language that implements OOD is called an object-oriented program. An object-oriented programming language. Sorry, that was a mistake. So, a programming language that implements OOD, which is object-oriented design, is called an object-oriented program language. It's also used to learn how to represent data in computer memory, how to manipulate data, and how to implement operations. It's also used to write algorithms and implement them in a programming language. So, object-oriented programming is used to learn how to combine data and operations on the data into a single unit called an object. Was designed to implement OOD. OOD is used to structure design, or is used with structured design, right? So this is a simple C++ program. From here to here, that's a simple C++ program. So here you can see C out, sorry, it should be in small letters, C out, then hello world. Where is it? C out, hello world. Then you end line. So this is just a simple C++ program. A simple C++ program. So if you run it, cout is used to print what you are expecting, what you want to see. That's cout. So if you run it, it prints hello world, as you can see right here. All right. So now to processing a C++ program. To execute a program written in high-level language such as C++. So C++ is a high-level language. So if you want to execute a program like that, you have to use an editor to create a source program in C++. So in this case, the editor is this C line I'm using. And this is the source code program which I'm using. So in a C++ program, statements that begin with the symbol hash are called preprocessor directives. So this whole statement is called a preprocessor directive. Yeah. So these statements are processed by a program called the preprocessor. So these are the directives, and it's processed by it's processed by a preprocessor. And second, you use the compiler to check that the program obeys the rules. So as I run the computer, there's an inbuilt compiler in the C line which compiles everything and see if it's correct, then outputs it and translate to machine language, which is the object program. Then the software development kit may be used to create a program. Now we have the linker, the loader, the linker and the loader. So the linker combines objects program with other programs provided by the SDK to create executable code. So this means that the linker is to combine the object code, which is all these codes, with other programs provided by the SDK to create executable code. The loader loads executable program into the main memory. So after the linker has combined the programs, the loader will load. So the loader is like a compiler. It loads it into the memory. The last step is to execute the program. So that's processing a C++ program. That's how it works. So there's like a flow chart used. So in the flow charts, you start with, or let me write it down here. So this is basically the structure. So step one, is the word editor. Step one is the editor. Step two Step 2 is the preprocessor. Pre shit, sorry. Is the preprocessor to the preprocessor. Step 3 step 3 step 3 is the compiler. Then in between there's a library. I'll explain that one sooner. Then step 4, sorry. Step 4 is the linker. Step 5 is the loader. As you all know, this is the loader. Step and the final step is the execution, which is step 6. Execution. So these are the steps involved in processing a C++ program. So the step 1 is the editor, where you write your source code or your programs. Then the preprocessor processes the programs using the preprocessor. Then the step 3, which is a compiler, it carries or executes everything into the memory. Then the library, which is the linker. Since we all know the linker is to combine object codes with programs, so the object codes are in the library. So the linker takes the object codes from the library and combines it with the programs for the loader to load into the main memory and executed by the machines or the CPU or the control unit. Okay, so compiling and linking. Run to compile and link, you run code through compiler. If the compiler generates errors, you have to first of all look at the code and remove errors. You run the code again through the compiler. If there are no syntax errors, the compiler generates equivalent machine codes. The linker links machine codes with system resources. Alright, and after that, once compiled and linked, the loader can place program into main memory for execution. The final step is to execute the program. The compiler guarantees that the program follows the rules of the language. So that's it. The compiler will guarantee or the compiler guarantees or makes sure that the code follows the particular syntax. That's just basically the compiler. And then the loader loads the programs into the main memory. That's the difference between a compiler and the loader. Now processes. Process is a program loaded into memory along with all the resources needed by the program. Let me take it again. Process is a program loaded into memory, the main memory, along with all the resources needed by the program. Each running instance of a program is a process. Each running instance of a program is a process. Now, each process runs independently. All right. So the next one is threads. Threads. A thread is a unit of execution within a process. As you all know, a process is what a program loaded into the memory. So you loading a program into the memory is called process. A thread is a unit of execution within a process. That means this whole the computer executing this thing makes this line the thread. Yeah. Multiple threads can be initiated from a single process. There are single-threaded processes and multi-threaded processes. So the the compiler executing every line of code is called the thread, but the whole thing is called the process. So the process of executing each line is called the process, which the process of making a thread is called the process. I hope you get it. Something like that. So basically, um, the compiler executing this line, which is hash include this one. Sorry, this is not supposed to be. So the compiler executing this line of code, this line of code being executed is called a thread. Then so each line of code that is being executed will be called a thread. Then the whole thing will be called a process. So the program starts out as a text file of programming code. A program is compiled or interpreted into binary form. The program is loaded into memory. So once as the program is loading into the memory, that is the process. Now the program becomes one or more running processes. Processes are typically independent of one another. Threads exist as the subset of a process. Threads can communicate with each other more easily than processes can. Alright, so that's just introduction to introduction to the C++ program. So this is, I don't want to erase it, so let me say steps involved in executing a C++ program. So now what I'm doing right now is commenting, which I'll elaborate on it further in the videos. So basically, commenting is just um, to make sure that the compiler doesn't run unwanted programs like this, or these are not part of the programs. Since I told you, this is the initial or the standard programming C++ program. This is a standard C++ program. So this whole thing I wanted to, what I've just done is commenting. There is single line comment and then there's multi-line comment. Single line comment is with two forward slashes, whilst multi-line, which I've done here, is to with forward slash and asterisk, then you do it the same at the other end. So now we are up to chapter 2. So this is just the introductory part of the C++. Now we are going to Chapter 2. In chapter 2, you're going to look at um, types and declarations. Types and declarations. So let me do it this way. I'm looking for this to separate. I'm trying to separate the two lines, the two chapters. So this is chapter 2. Chapter 2. Then this is chapter 1. Or never mind, I can do everything in it. Oh, don't worry. Let's continue. Yeah, let's continue. So in chapter 2, I said you're looking at types and declarations. Types and declarations. So in this case, I'll introduce you to C++ types. You learn fundamental types such as booleans, character types, integer, floating points, void, and sizes. So typically these are the types, which is boolean, character, integer. These are all called, they're also called data types. Data types. So boolean, character, integer, string, and etc. So you learn that in a short time. So let me comment this one because I might use those codes I wrote earlier. Let me just continue. Then you'll also be introduced to declarations, how to declare a data type or a variable or constant. So let's start with data types. Data types refers to the various forms that data can be represented in a language. So which are this? So types, also called data types. Also called data types. They are just various forms in which data can be represented in the language. So these are the examples. And categories of data types. Categories of data types. We have the integral types, integral and floating point, enumeration and classes, and the fundamental types. The integral types are all these. Integral types are all these. Then integral and floating points are called arithmetic types. Yep. Then we go to data set. Data set. So data sets. Data set specifies the range of values a data type is composed of. Let me take it again. So this is the difference between data type and data set. Data type is just a ways in which you can represent data in a language. But data set is what it specifies the range of values a data type is composed of or can hold. Each data type has its data set. So integer, the data set for integer is whole numbers. The data set for integer is whole numbers. Whole numbers. Then the data set, so let me add something, floating point or float. Floating point double. So the data set of boolean is what? True or false. A data set for character is what? Letters. Letters. Then for string is what? Words or group of characters. Yeah, group of characters. Then for floating point is decimal numbers. Floating point or double. Decimal numbers. Then we go to data sizes. So this is data type. These are data type. Then all these are data sets. All the ones here are also data sets. Then we go to data size. Data size. So data size specifies the amount of memory a data is allocated in a data type. Specifies, don't mess all this up. Don't mess all this. Data type, then data sets, and data size. They are all different. So data type is, let me write it down here. Data type, there are ways to represent data. Represent data. Wow's data set. What data set is what specifies the values a data type is data type consists of. That's the difference. Then data size is what? Data size is what specifies the amount of memory allocated to a data type. Yeah, so this is basically the definitions Data types, they are ways to represent data. Data set specifies the values a data type consists of. Then data size specifies the amount of memory allocated to a data type. All right. So in this case, integer is what? 4 bytes. Integer is 4 bytes. Floating point also uses 4 bytes. Float or floating point. Float can also be called floating point. Also uses 4 bytes. Double uses 8 bytes. As the name goes, double uses what? 8 bytes. It's just multiple of a float. That's a double. Then character or char uses 1 byte. Boolean also uses 1 byte. Or bool uses 1 byte. And then string uses 32 bytes. Now let's go to integer types. Those are types of integer types. So integer as the name goes, whole numbers. So it can be minus like 670 something to positive minus infinity, probably minus infinity to positive infinity. Examples: we have 78 5 minus 679 etc. All those are examples of all these are examples of examples of integer type. So this is how we write integer in the C++ program. So if you have this, you write it in the body. So it's written as int. You can say int x or int a equal. So this, what I've done here, this thing or this line of code, this statement I've written is called sorry. Int a. Let me use int a. This is called variable declaration. It's called variable declaration. This is called initialization. Yeah, don't get confused. So you have to put, it's not following the syntax. This has to follow the syntax. So this is variable declaration without the equal to and the value is a declaration. Then with the equal to and the value makes it an initialization. Then we also have a constant, which is constant declaration. Constant A, let me see, B, constant C. This is a constant declaration. You already know what I want to do. Then const this is a constant initialization. As a constant initialization. So there are two types of floating point types. There are floating point. There are two types of floating point. Let me carry this. Copy. And put it under integer type. There are two types of floating point. There is the double and the float. There's a double and the float. The reason why they're different is because float has a range of value that can be accepted, which is from 1 to 7. Then double goes from 7 to 15. Yes. So you use double for larger range of values, then use double for use float for smaller range of values that have like 7 or 6 decimal places, but for double is to 15 decimal places. The float point types are decimal values. So what I'm talking about, everything I'm talking about is about everything I'm talking about is has to do with decimal points. So for double, it requires decimal point range of 0.15, while float is 0.7. Yep. So double, this is the syntax for writing double, you can say double amount equals double amount equals 3 point. Can write all these values for that. Then float is what? Float result 98.50. These are the syntax. Now to the Boolean types. Boolean types, as I said earlier, is just true or false or 0 and 1. So for Boolean type, let me write it down. Boolean type is true or false. So the syntax is Boo is raining equals true. Now, what I've done here is called an identifier. I didn't state it earlier, but this is an identifier. This is called an identifier. Identify, it's if you don't want to write, or it's just a syntax where you're not supposed to write sentences. There are rules governing identifiers. The first rule is the first letter should be small letter, or if you want to interchange it between letters, you can. The first letter should be small letter, then the next word should be capital, and there should not be any space in it. The other rule is no characters or numbers. Then this is a different. There are types of identifiers. This is called a camel case. Camel, because it looks like camel. See, small letter, big letter, small. That's how a camel back is. Then we have a Pascal case where you use you have the camel case, the Pascal case, and the snake case. Then there's another one, the Hungarian case, but it's an old one, so it's not mostly used. So let me write that further down. It's raining. This is a camel case. And then I can also write it's raining. This is the snake case. Snake case. Then we have the Pascal case, which is the first letter is capital, the rest is small, then the second letter should be capital. Yes, this is Pascal case. This is for Pascal case. Alright, so that's for Boolean type. Then I have the character type. Characters, as the name goes, just letters. So in that case, character type you have is represented with char. So you can say char gender. This is the syntax. Char gender equals. Now for character, you need to put them in a single quotation. This is a syntax. It should be in a single quotation. Then you have a string type. The string type, which is a group of characters. So that one is string name equals string name. This is in double quotes. String name Kofi. So this is the syntax for writing a C++ program. Different data types. You have to put this semicolon, which is a terminator. You have to also respect this. A string carries double quotation, a character carries single quotation. Boolean is true or false. Floating point is decimal numbers. Integer has the name int, right? Now there is void. Void is just simply, it signifies absence of information. Yeah. So that's void X, void R, void, yeah. Then you have signed and unsigned. So both are type modifiers. The signed has both positive and negative values, while the unsigned only has non-negative values, which is 0 and positive values. Yeah, that's different between signed and unsigned. There are also types of data types. There are also data types of modifiers, but the signed uses they are for negative and positive, whilst unsigned is for only positives. So signed type, we have sign int x like that. Unsigned, so let me write it down. Sign and unsigned. Sorry, not is sign. So signed, the syntax goes signed int x equals minus 58 or 5. Then the unsigned int x only carries positives. There are other fundamental types, which is the short, the long, and the long. So the short is what it carries 2 bytes, the long is 4 bytes, the long is 8 bytes. Then we have composite types, which are pointers, arrays, and reference types, which we will cover in later chapters. We have the user-defined types, which are the data structures and classes, which we also cover in in later chapters. Now, declaring multiple names. So we have the local scope and then the global scope. The local scope is this way. Local scope is actually written before the int. Sorry, global scope is written before the int main. So let me say I have const double pi as the name. Oh shoot, const double pi. This is called the global scope. The global scope. Then if I put, let me take this array and put it this one. Then if you have this int x equals 5, this is called the local scope. So the difference being global scope is before the int main function, or the local scope is inside the int main function. Now, if you have multiple values like int x equals 5, int y equals to 5 too, then you see cout sum. Sum x cout x plus y. So if you have this, if you don't want to write, or let me say it this way, if you want to write multiple variables, you don't necessarily have to repeat all the data types in all the variables. You can just put a comma here and paste it. Sorry, that's it. Paste. So int x equals 5. So instead of writing the data, repeating the data types for all the variables, you can just put a comma and then write it there. So when we run this, sorry, there's a, let's see where the error is. Line 27. Where's line 27? it gives you 10. You see, it gives you 10. So, or you can say result, let me see, int sum equals result. I'm trying to find out something. So let's just go by this one. See out int sum equals so basically give you 10. That's what it's supposed to be. So you just added it for you. So yeah, that's it. If you don't want to repeat the data types, or it's not like if you don't want it, it actually looks professional like this by putting comma and then yeah. So basically that's it for this chapter. So let's go over what we've done chapter 1 and chapter 2. Chapter 1, I just introduced you to the C++ in general. We have the data type, the data sets, the data sizes. Whilst in chapter 2, we went in details. We found the syntax for or each data types and learned about global scope and local scope, and declaration and initialization and other various data types. And yeah, so that is chapter 2. So now we're going to chapter 3. Now to chapter 3. In chapter 3, we are going to learn about expressions and statements. Expressions and statements. It's about types of expressions and statements. So expressions are just combination of variables, operands, and operators. Operands are basically the signs like plus. Sorry, operands are the numbers. Like if you have something like 2 plus 3, yes. The operator is the plus, and then the operands are 2 and then 3. Yeah, I hope you get that. So basically, the int x equals this, all those things are all expressions. 2 plus 3 is expressions. Yeah. If all operands are integers, expression is called an integral expression. Let me repeat it again. If all operands, like 2 and 3 in 2 plus 3, if the 2 and 3 are integers, which they are, that expression is called an integral expression. Then if all operands are floating point, which is decimal places, like 2.3 plus 3.5, then the expression is called a floating point expression. Then if an integral yields integral results, no, sorry, an integral, yeah, if an integral expression yields an integral result, it's called an integral expression. Okay, it's clearly shown. Then we have mixed expression. Mixed expression, as the name goes, mixed. It can be floating point and then integral. Yes, all mixed like 2 plus 3.5 or 6 divided by 4 plus 3.9. Yeah, and all those ones. Then we have the conditional expressions. Expressions where the value produced depends on the value of a condition. That's conditional expression. They are just the expressions where the value produced depends on the value of condition. There are the relational expressions. We have the relational expression. The relational expression yields results of type bool, which takes a value true or false. Those are relational expressions. So let me just write it down. Expression. That's what we're learning. In this chapter, expressions and statements. That's what this chapter entails. Expressions and statements. So types of expressions. We have the types of expressions. We have the integral type, have the floating point expression. Floating point expression. Then we have the conditional expression, which is based on a conditional value like if, else, maybe. Conditional expression. Let's see. If, else. I have the relational expression. That's the boolean. True or false. Have the mixed expression, logical expressions, which combines two or more relational expressions and produces a bool type. Yeah. Mixed expression. And then we have the logical, which is what? Two or more relational, then produces a bool type. And the pointer expressions, which uses the end. Let me write it down. Pointer expressions. Which uses the upper sound X, then PTR hashtag, or the PTR plus plus. Then we have the ending expression. The ending expression tells the system that you are done with your expression instruction expression creation. So we use the semicolon for ending expression. Then comments, I've already told you about comments. Mhm. Then we have statement. A statement is a single instruction that performs an action. A single instruction that performs an action. Statements are the building blocks of C++ program. So types of statements. We have the selection statement. That's statements used in decision making. If switch. We have the iterative statement. Statements used to express iteration of tasks. So let me write it down. Statement types. We have a selection statement for decision making. If switch. We have the iterative statement used to express iteration of tasks. So that's the for loop, all the loops for while, do while, then we have the expression statement, which is a statement used to evaluate expressions. We have the declaration statement, the jump statement, which is a break continue. We have the compound statement. Yep. So now let's look at the selection statement. So let's look at the if statement. This is a syntax for if statement. So using this one, to write the selection statement, you need to declare a variable first. So I can say int x equals to 5. So I'll say let's use age instead. Let's use age instead. It's carried that way. Int age equals to 5. So this is how the selection statement goes. If age is greater than 18, age is greater than 18, see out, you can vote. See out. vote. So help the let's make the computer ask um, the user for an answer, a response, which is called a user defined response. So since age equals 5, if age is greater than this, see out you can vote. No, let me not use 5, let me use 20. So it means age equals 20. So let's bring out something here. Let's bring out something. We say see out enter age, enter your age. Let's give it a user defined response to age. Then seeing age. Or if you don't really necessarily need this one, let me comment this. We don't need this one at the moment. You only use this one if you've not declared anything here. Yeah, so we'll come back to that. Let's just run this code and see. Sorry, forgot to comment this one. Then this one. Now let's run it. Shit. It gave you the answer. Since the int age is 20, the age is greater than 20, so it gave me you can vote. So now let's generate a user defined answer response. So I have to comment this line. Oh, don't worry. Let me do this int age. You have to still declare it. You have to declare it first. So this is a syntax for if statement or the selection statement. You have to first of all declare the variable, then write out wherever you want to write. I mean, whatever the steps requires. So in this case, it's asking enter your age. So let me say 20. Enter. You can vote. Now let's add something else. That's a negative statement. So here you say else see out else see out you can't vote. Let's run it and see. You can't vote. All right, let's run it again. Let me say 12. You can't vote. Yeah, that makes sense, no? So that's the if statement or selection statement. That's how it's used. That's how the if statement is used. Now let's go to the switch statement. The switch statement allows you to choose between multiple alternatives. It compares the value of one expression with multiple constants. Expression in switch statement must be an integral type. So this is the syntax for the switch statement. Let's comment this line. Let's comment this line. Then write it down here. You see what? This is the syntax. You still have to, let's say, let's use in the age, int age equals 12. You have what? Switch age so it's just basically it looks like the syntax is more of like the age statement, but this uses a different parameters or different numbers. So here we can say case 18. See out student can vote. But here you add break, because if you don't break, if you don't add the statement to keep on iterating this one. So you bring a break, then default. I have default cout student. So this is a default. If the so the default is 4. If the value inputted, or if the age is greater than, if the age is greater than 12, or let's run it and see. Let's run it. Okay, let's change it a little bit. Let's use greater than. Okay. Let's add something. Case 30. Yep. Okay, the reason being, all right, that's the problem. I didn't put something here. Let me close this one. Then run it. Student can't vote. All right, so this is how it's done. So since I've declared here already that age should be equals to 12, or I can put 18 here. So meaning any other age, if I put 18 here, it will give me student can vote. Student can vote. So it will give me student can vote. But if I put 20, it will give me this one, the one below, which is student can't vote. So this is how you use a switch case. You can put a different case there too. Case 20. Shit, times case 25. You see, you already blackened out this one because it's not pertaining to this um, initial standard here. So let's add something to it. Or let me do something. Yep, this one. Age is equal to 18. Alright, so this one, let's see what the value come out. Student can't vote. Wow. Okay, so let's do something here. Instead of default, I'll put another case here. Case, yes, this is supposed to be default. Default, sorry, it's supposed to be default. Okay, sorry, this is it here. This is it. So let me see. Put 10 here. Says students can't vote. But put 18 here. Mm, why isn't it? Alright, so that's the switch case. That's how it's being used. So the break statement exists for a switch or a loop immediately. Break keyword can be used to jump to the first statement that follows a switch or a loop. The continuous statement continues execution after a condition is accomplished. It is used in loops and has the opposite effect to the break. That is, the next loop is begun immediately. Now, you have let's go to types of operators. We have the arithmetic operators, the assignment operators, the conditional operators, the relational operators, and the logical operators. So the arithmetic operators are plus, minus, multiplication, division, modular, remainder. We have the unary operator, binary operator, ternary operator. The unary operator has one operand, while the binary operator has two operands. Ternary operator has three operands. Alright. Logical operators used to express logics returns a bool result, uses the ampersand, slash slash, and that's operator, an exclamation operator, which is the not. Mhm. Alright, you are done with this chapter. Let's go to the next chapter. So in the next chapter, we're going to look at iterative statements. We're going to look at the iterative statement. Now the iterative statements are for loop, the while loop, then the do while loop. Now the for statement. This is how the syntax goes. For the for statement, this is how the syntax goes. You start with for, then the initial statement, the loop. Alright, let me write it down. So for, start with the for, then you have the initial statement, initial statement, the loop condition, then the update statements. Then bring a curly braces, then the statement in the middle, and the body. Then you do what? You close with a curly brace. This for the for loop. So now the for loop, this is how you execute. The initial statement executes. The loop condition is evaluated. If the loop condition evaluates to true, the system will execute the for loop statement, and the system will execute the update statement after. So the system will continue to evaluate until the loop condition evaluates to false. So let's put that in practice. Wait a minute. Let me comment this. So let's comment. So this is how the for loop runs. So I can say for int I equals 0. You terminate. That's the statement, the conditional state. That's the initial statement. And this is the conditional statement. It's less than 0. I plus. This is the update statement. I plus plus. Then you put here cout I. And Let's run it. Okay, yeah, we didn't put value, any value there. Let's come here and see. Yeah, we've updated the formula, so it will be clearer now. Yep, this is how it runs. So since I, because this is the initial statement, as I said earlier in the syntax, so which is this, the initial statement, and this is the conditional statement, I less than 5, so it will output numbers, the numbers less than 5. Then I plus plus, that means from 0 going, yeah, you add 1 to every number to get this. So that's a for loop. Now let's go to that's the syntax, right? Let's go to the while loop. This is a while loop. So for the while, this is a while loop. While put what? The expression. The expression. Then you have this. And put your statement. Statement. And put the updated statement. Then close it. So let's run it. So if you are using the while, you have to first of all declare the this value. So this is the while loop. This is the format. for the for loop, all the statements are in one curly braces and the statement is there in the body. But for the while loop, you first of all get the initial statement, then the while, then the conditional statement, then see out, which is a statement, then you put the updated statement. So let's run it. See, give you the same thing. Same thing. Now let's go to the do while loop. So for the do while, this is the syntax. So this is the syntax for the do while loop. So let's go and then run it. So you have int I equals 0, terminate it, do, then you say see out I, end line, then wow, I is less than 5, I plus 1. So yeah, this is how the do while loop goes. You declare it, or this is the initial statement. You bring your do, then the your statement. Then you have the updated statement, and the while loop with the loop conditions here. So now let's run it. Yep, that's it. So that's it. That is it with the now to exit from loops, you have to break it. Or you put a break there. The break breaks out of the nearest closing switch. Now, exiting from loops is the condition of an iteration statement. For a for, a while, or do statement is omitted, the loop will not terminate unless the user explicitly exits it by a break, return, go to, throw, or some less obvious way such as call or of exit. Now, a break is used to break out of the nearest and closing switch statement for iteration statements. Then we also use a break when we need to leave the loop body in the middle. Now, exiting from loops again. So the break statement is used for two purposes: to exit early from a loop, to skip the remainder of the switch structure. So yeah, those are the two ways of using the break. Mhm. Sometimes we don't want to exit the loop completely. We just want to get to the end of the loop body. So a continue skips the rest of the body of an iteration statement and takes you to the end of the statement. So when executed in a loop, it skips remaining statements and proceeds with the iteration of the loop. Yep, so that's it. So we're going to move on to the next chapter. Now, in the next chapter, we're going to talk about uh, in the next chapter, we're going to talk about functions. Yep, we're going to talk about functions. So, functions in C++ are blocks of code designed to perform a specific task. So, they are blocks of code designed to perform a specific task. They are fundamental for organizing code, promoting reusability, and making programs easier to manage. So, types of functions: we have the user defined functions, standard library functions. So, the user defined functions, they are created by programmers to perform specific tasks. That's user defined functions. We have the standard library functions. They are predefined functions available in C++ libraries. As example, the std cout, std square root. So, and we also have virtual functions. Those are functions in base classes that can be overridden in derived classes, enabling polymorphism. We also have inline functions. All these ones you will learn that in later chapters. So the benefits of functions: for modularity, which means to break down complex programs into smaller, manageable units. That's modularity. Then we have the reusability. That's write code once and use it multiple times. Also, another benefit of functions are as abstraction, which is hide implementation details, focusing on what the function does rather than how it does it. Improve readability, makes code easier to understand and maintain. So we now have function declaration. We have three types of writing function. So function declaration, function definition, and then function calling. So this is a syntax for function declaration. We have the return type, function name, then brackets, then parameter one, parameter two, close brackets. So a typical example of the function is int find sum, brackets open, int first num, comma, int second and bracket close, semicolon. Then your int main. So for your information, the function declaration is a global scope. You write it as a global scope. It's above the int main. So the syntax again, int find sum, bracket open, int first noun, comma, int second noun, close bracket, semicolon. Then you have int main, then your int main function, yep. Then cout find sum 1, comma 2. So this prints out 1 plus 2. Yep. So that's for function declaration. So the to declare a function is just the syntax is just int find sum, int finds that the syntax goes like return type, function name, parameter 1, parameter 2. That's the syntax. Then function definition. The function definition is a function declaration in which the body of the function is presented. So when you present the body, it becomes a function definition. But when you get the global scope of the function, that's just function declaration. That's when you declare the function, the global scope. So function definition is just adding a body to the declaration. So the keywords are return type, function name, parameters, function body, return statement. So this is the program for function definition. We have the so after writing your int add, int first noun, int second noun, you put the body. Mind you, this also is a global scope. It's written before the int main function. So you add the body to it. Yep. Then we have arguments. They are actual values passed to a function when it's called. So the syntax is for function underscore name, brackets open, argument 1, argument 2. So other arguments, you have references, pointers, and arrays. You have default arguments. Default arguments are actual values assigned to parameters during function definition or declaration. Syntax: return type, function name, type 1, type 2, name equals value. So default arguments is there's an example: int get sum, bracket open, int x, comma, int y equals 20, bracket close, then the curly braces, then return x plus 1. So the argument there is cout. That the argument comes after the int main, which is a local scope. So you cout get sum 5. So default arguments, if you include the default arguments like get sum 5, comma 15, and then you're outputting x and y, and you say the first statement is get sum 5, automatically the computer adds the 15 to it because it's a default one. Unless you put your own value there, it doesn't put the default one there. Now, function call. To execute a function, you call it by its name, followed by parentheses and any required arguments. So the syntax is for function name, argument 1, argument 2. Function overloading. Defining multiple functions with the same name but different parameters. Let me take it again. Function overloading. Defining multiple functions with the same name but different parameters. There are 3 cases. Case 1, so by having different number of parameters. Case 2 is by having different types of parameters. Case 3, both different number and types of parameters. So function, the case 1 as well. Um, int add int a plus. So let me write that one down. So in general, this is what I'm saying. Functions are before that. So you see int add, then your parameter 1, which is a. No, int add, let me say, yep, int a, comma, int b. Then you bring your return a plus b. All right, so this is this here is function declaration. This thing, this here is function declaration. Everything here is function definition. Function definition. And then you say cout add 5, 10. So this is the argument. This is called the highlighted line is called the argument. So if you run it, you're going to get the answer 15. So the default argument, this is what I was talking about. If I put here to be b equals 10, and I just put this, since there's a default number here, and the body says a plus b, that's a definition, the function definition a plus b. So since this is a default, it automatically adds the 10 to this. So if I run it, I'll have 15 still. But if I add my own number, b should not be. So if I add 20 here, yeah, you see, automatically assigns the number to the b. So it removes this and prints out the value, which is 25. You see, that's what I was talking about. And now the cases the cases I was talking about, we have the first one is what having the same parameters, which is this is the same parameters, right? That's the first case. The second case is when this is has its different types of parameters. So if here is double and here's int, that's the second case. It will still give you the same result. 25. Now the third case is when different types and different number of parameters, which is alpha add C. Sorry, let me say float, or let me say double C. Double C. And here I'll say C out, comma 5, and line. Now this gives me 30. Sorry. A plus B plus C. If I run it, I get what? Alright, so this is it. That's the three cases I was talking about. So that's it for this session. Hope to see you next time with more C++. So just practice everything I've taught today and understand it well. Yeah, so that's basically just the introduction to C++, just a handful of it. So thank you.